So you might be wondering where this omega comes from and how we're using sines and cosines to describe a box moving back and forth in a straight line on a horizontal surface. Well, let's take a look at this example. I've got my box on my horizontal surface attached to the spring, and it's going to oscillate back and forth on that surface. I'm going to take a disc, a big circular disc, and I'm going to hang it on the wall just above my box so it can rotate. The center of my disc is here. That's the axis of rotation, and my disc can rotate. And I'm going to stick a little peg on that disc sticking out. So there's a little peg sticking out right there. If I look at the side view of my disc, here's a side view of the disc, and the peg is sticking out right there. And you can see I've got a bunch of lights on the ceiling pointing straight down. Light is coming straight down from the ceiling. And when the light hits that, it's going to leave a shadow on the ground below. So I'm going to get a shadow right here on the box when it's sitting there at the equilibrium position of the spring, and my disc happens to be in this position. So if I take my box and I displace it by some distance a, some amplitude a, and I let go of it, the box is going to get pulled in this direction. It's going to move through the equilibrium position, and it's going to end up over here at negative a, and it's going to come to rest momentarily at that point. And if my wheel is turning at just the right speed, my peg is going to be over here at that instant, and the shadow is going to be on top of the box at that instant. The box is not moving left or right. It's at rest. It comes to rest momentarily at that point. And the shadow from my peg is not moving left or right either, because the peg is actually moving down at that instant, right? It's moving tangent to my circle. So its shadow is not moving left or right either. An instant later, my box is going to be over here. And it's going to be moving in this direction. Well, where's my peg going to be? My peg is going to be over here, and it's going to be moving. So the shadow is right on top of the box, and it's going to be moving with the same speed as the box. And an instant later, my box is going to be at the equilibrium position, moving with its maximum speed to the right. And where's my peg going to be? It's going to be right here, moving to the right with its maximum speed. And the shadow is going to be right on top of the box. And you can see that if I pick my speed just right, if I pick this rotational speed, omega, just right, the shadow always moves with the box. Has the same speed, the same amplitude. It always moves with the box. So we can convert this horizontal, linear motion, cyclical motion of the box into circular motion. We can use the frequency, f, the number of cycles it completes in a given amount of time, and convert that into an angular frequency, omega, the number of circles that my peg completes in a given amount of time, the number of radians per second the peg moves through. Then I can use sines and cosines and circular motion to describe the cyclical nature of anything, even if it's an object moving back and forth in a straight line.